Hello and welcome back to another Cables.gl video. For this tutorial, we are going to use the January 10th prompt generative music or aleatoric music. So here is what we are going to make in today's video. So this is kind of like an interface that I designed to kind of create a basic melody. So these are two control panels that I can use in this case to kind of tweak. And this sphere I just put in for some audio reactive kind of a scene. So let's get started. So we have a clean patch here. So in order to kind of start off with generative music, first we need to kind of get the output of the audio. So for this video, we are going to start in an inverted way. We will start from the end and then kind of go towards the beginning. So we have an output that will kind of receive our output audio signals and then kind of let us hear the output. So this we are going to connect to a mixer, which basically mixes different kind of audio signals together. And to this, we are going to include an op, which is oscillator Kirel. So this is a custom op that I am using this awesome cables user guy called Kirel. So I borrowed this op from him, the op code. So what this op basically does is it has like a frequency, and then if I play it, I get like the basic note corresponding to this frequency. So we can kind of play around with the frequency and see how it goes. So currently it's kind of like a very flat single note kind of thing. That is why we have a mixer where we are going to like have different kind of ops and kind of play all of them together in some probabilistic manner. Okay. So also I am going to kind of reduce the volume for all of these to 0.1 so that it's not too loud on the ears. Yeah, and this I guess I will let them be for now. Okay, so now that we have this, what we are going to do next is get some values of the frequency in here. So for this, we can use something called MIDI value to frequency. It basically converts a MIDI value and then it gives the frequency for that particular value. So you see, if I change this number, then it gives me some corresponding frequency, right? Okay. And there is another op in cables which is called musical scales. What this op does is it has like a root node and a scale type, and it outputs like a series of MIDI note array. So this gives us kind of like different kind of MIDI note values as in the form of an array basically. So we are going to get this out, do an array get number, and connect this to this MIDI value frequency. And now that we have these two, we are going to add in a timer. So in this case, like if I just play this again and then start changing these, so you see that these PD value kind of changes, and for that we get like the corresponding frequency, right? So let's switch it off. So what we want to be able to do is like feed in a bunch of random numbers to this array get number and drive this so that like every time we get like a different sort of sound or tone. So, and also array get numbers are like indices, like whole numbers and not fractions. So we'll do a floor and then add this to a random numbers of. So what random numbers does is it takes in a seed and then it generates like random numbers from in like a certain range, right? So for now, let's take the minimum and maximum values as um, 4 and I don't know, 12. Like you can take any values and then connect this. So this is a timer and it's kind of like will be acting as a seed value in this case. So you see that it suddenly kind of starts working. Now if we play this, so you'll see that like it sounds very weird. That is because even if there is like a fractional change in this value, then this seed kind of changes. So we have this constantly changing random value or random number. So we'll add another flow here. So now you see that there is some audio coming in, but it's kind of like sometimes it comes, sometimes it does not come, and it's kind of random. So we can also do 0 to 7. So why 0 to 7? Because this array, which is coming out here, is consisting of like 7 values. So I guess it will be 0 to 6 if you always want to have some audio. But if we increase this maximum value to something else, like let's say sometimes we won't get a value when it's kind of like going out of range, right? So it basically gives us like 0 for those values. But this is kind of like the basis of how you can get like a bass melody of sorts. Now, if you change this value to something else, so you can control the speed of this entire thing. So now that we have this basic kind of setup in place, let's add a few more of these things. So I will just copy paste this 4 times, connect different random numbers to these floor values. So we have like different kind of outputs. So that is like a sounds like a chord, although it's not really. So you already see that we have a basic audio engine sort of going on here, right? Now what I want to be able to do is to switch it on and off using the right mouse button. So I will add in a mouse up and the right mouse button basically goes into a toggle pool. And this I will use it to kind of switch the timer on and off. So you see that if it gets stuck somewhere, then it has like this constant note, and otherwise it kind of keeps playing. And in the oscillators, we have this play button as well, similar to this timer. So this is the play button for the timer, the play input port. So we'll connect this same output, Boolean output to this Kiril oscillator nodes. So now you can switch it on and off, right? So that's kind of like the basic part of how to control like a basic audio engine. The other thing that we are going to do now is to have like a clean interface for it. So we will move this over to the side and start off with like our usual ops, the main loop. Plug this into a sequence operator and then a render to texture for our geometries and an image compose draw image pair for coloring and stuff. Connect all of the input output texture ports and hook them all up to a full screen rectangle op. Drop in another sequence operator because we'll have like a bunch of stuff going on in here. So let's drop in another sequence so that everything is clean. Uh, then we are going to get a transform, transform, add in a text mesh, make them small, add in another transform and a text mesh. So why are we adding transforms and texts? Because we want to be able to display musical scales and stuff like that. So in this particular op, we have this root node and the scale type, right? Now we can get this out as like, the current scale value, what is selected, and we can go ahead and change all of these things. But in this op that comes by default, the only thing that we can get out is the minor. So I have made like a slight tweak in the op for this that also gives me this current tone value as well. So if you go to this particular button in here and you do this edit code thing, so you get access to this code, right? You do not have to be very proficient in order to kind of tweak a bunch of stuff, but you do need to be able to understand what is going on in here. So as in this case, we had this particular statement that said current output current scale dot set, and then it is getting that current scale output in here, current scale, right? And in here, it is saying constant out current scale, and then it says current scale. So this is kind of what was there before. So we added this other part, which is the current node. And similarly, we also added this thing so that we get the bass tone, right, from this thing. So whatever root node is kind of selected, we get it in our output as well, so that like we can display it. So now what we are going to do is take this and then kind of select, uh, plug one of them, plug the first one in here, plug the second one in here, and then we see that it says C and minor. We are going to align them both left so that it becomes easy to control later. Uh, Make them kind of small, so like scale them down 0.1. Uh, let's get rid of the helpers. So you see that they are overlapping at the moment. So we are going to kind of distance them out a bit. So let's do -1. So you see that they are kind of a bit far away. So you can see both of them clearly. And then like let's uh, put them somewhere -1.25. Let's change the aspect ratio to 16:9. And let's put this up to 0.86. Okay, so we have our numbers up here. And yeah, so we have the two values in here. Um, we'll just set them to kind of linear so that it's bright and easy to read. Okay, so now that we have these two up here, so basically this is how it comes in this. Now the next part that we are going to do is to add in our rings that you saw earlier to control these two values, right? So for that, what we are going to use is something called the picker. So it basically gives you, it basically tells you yes if your mouse is kind of hovering over some elements. So now that we have the picker, we are going to add in picking materials. They kind of go hand in hand. So it also, so this is like a, what do you call, a superset of sorts, and then you can attach like multiple picking materials. Since we are going to have two rings, so two picking materials for the two of them. Then I'm going to drop in two circles, circle 1, circle 2. This is going to form like, so why two circles, like I will explain in a bit, and then a basic material. So in the original video, if you remember, we had like a ring and a slight bar. So let's get this out of the way. So for the first one, we are going to draw a line. So this is what happens. And then we are going to change this value to 0.96 so that it's nice and big. And similarly for this one, 0.96, I guess. Um, and then we are going to connect this back to this one. Now we have these two circles overlapping. In this, for the inner radius, we are going to do a 0.92, something like this, so that we have like a nice clear circle. Now look at what happens in these. So this is like Boolean. So we are going to use a this bool for both of these, and also for this to kind of test out our pickers, right? So this is kind of like the master one. So let's, so if I am hovering above this, so you see like these two kind of glow. So this is like a finer control if we want to select something uh, over the other, since we are having like two kind of pickers, so two picking materials for different objects. So okay, that's one. Now this circle, what happens is there's something called this percentage, right? This percent. So if I increase this value from 0 to 1, it becomes a full circle, otherwise it's like a partial circle. So now what we want to be able to do here is use the mouse wheel. So we'll drop in the mouse wheel up and then connect this to delta sum. So this output is basically the delta. So if I am scrolling, then I get this number, right? And then hook it up to a delta sum, and then whatever value I get, I want to map it using this map range operator. And this delta sum, I want it to go from, I want it to be limited to like, let's say 1 and 12. And then I want to kind of subtract it by 1. Okay, so for this we get like 0 to 11 values, and this is something that we are going to use to drive our root node index. So for the root node index, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total 12 values. So let's do a floor, connect all of these root node indices. So this is just for like a demonstration purposes. You can obviously connect different things to different things and see what difference does that make. That will definitely result in a different kind of music. We'll add in a number to kind of keep things neat and clean and not overlap with each other. Connect this to this. So now if we, okay, so the other thing that we want to do here is like it goes from, it does not go from 0 to 1 anymore, right? It goes from 0 to 12. So here we are saying like 1 to 12, but here we are saying 0 to 12 and it does not make sense, right? But why are we doing this? I'll just show you in a bit. And this new minimum and new maximum values will set to 0 to 1 because that's what we need for this percent here. So we are going to link these two. So now you see that this is set to this thing, right? And if we scroll, then this happens, right? Now, if we set this to uh, 1 to 12, like we had done for delta sum, then initially it will be like, empty. But we also want to kind of indicate this as the first step. So that's why it's like 0 to 12 and not 1 to 12. And that's why we are taking here 1 to 12 and not 0 to 11, basically, even though there are like, 12 values. I mean, there are like other ways of handling it as well, but it's okay. Uh, so from here, now we are going to connect this to this active toggle here. So if we are hovering about over this, then only I can do this. But if I do it somewhere else, it does not work now. Okay. Now we are going to kind of like copy paste all of this stuff into here and just connect this for our second. Okay. Okay, so now that we have this second set, we are going to tweak the values of the circle so that we have like a slightly smaller circle. So let's set this to 0.72 and set this to something like 0.9, and this other one as well, we are going to set it to 0.72 so that we have this inner circle. And then we are going to okay, so we have two different circles. So there is this floor which is kind of driving our root node, right? So we are just going to make a copy of this for our scale, connect them all to the same scale value, connect this uh, to this here. And then if we scroll this, our scale changes. So this is for our scale and this is for our root node. Now we connect this to our root node here and this to our scale. So you see if we change this, then this kind of changes. And if we change this, then this other root node value changes. So like our basic kind of interactions are sort of in place. So just hit save because that's very important. If sometimes something gets stuck, then it's kind of tricky to get things back. Now we are going to change the delta sum values for the second part because unlike the first option, the second option is not 12, but I think it is 28. So we'll just reconnect this. Change the delta sum value to 1 to 29 and this to from 0 to 12 to 0 to 29. So it becomes kind of smaller. And now if we go all the way, then you can see like we can access all of the values through this, right? So if we try and play this and kind of scroll this, let's see if anything changes or not. So you see that like it's kind of working. We'll just pause this, go back to our patch. So let's add in a clear color op. And then what we can do is hook this up to a map range. Set this value to 0.2. Add this to our alpha channel. So you'll see that this is gray, but when I hover on it, it becomes like highlighted. We are going to add the same to this one here. So all of them are kind of dim, but if I hover on them, they are kind of active. Otherwise, I cannot scroll through them. So it's easy to kind of change all of these values now. So the next part that we are going to look at is making things audio reactive. So in order to do that, we are going to add in a sphere. So we have a small sphere in the center, and then we are going to add in a vertex displacement map to this. And we are going to plug in an image compose with a Perlin noise and use this particular texture to kind of drive this. So we have this Perlin noise. Okay, it's too big, so let's reduce this value to 0.1. So we have like a nice little sphere in here. Then let's drop in a PBR material light and PBR material, and this goes sorry this goes to a texture of RGBE texture. Okay, and this we are going to set the color to something gray value like this. And now what we want here is to get the output value from one of these, the frequency, and plug this into this vertex displacement map. However, what happens is that so if we look at this number and play it, so you see the different ranges for this value. It is kind of like a very high range. So we are going to map this back to something in between 0 to 1 because like this value is like, if you go high then it becomes too big and we can't see anything. So this also we are going to smooth it out a bit. So let's connect it to a map range. Uh, let's take this value as 2000 and this as 0.5 and that is 1. Connect this to this extrusion value. So you see that there's like this very boring kind of thing that is going on here. So we'll smooth out these values by the smooth operator. And we'll plug this in here and we will get the output from here. So now you see that it feels like more natural compared to earlier. So finally, we are going to add in a color map to colorize the entire kind of thing. Uh, select some value from our color palette. So smooth everything out and then just take something that looks clean and nice. And that's about it. We have our audio reactive geometry and this audio generator sorts. So let's play it and see how it works. Yeah, it sounds really bad, but you get some idea of how to make something like this, how to go about getting started with like audio reactive stuff and generative music. Thanks for watching. See you in the next one.